3 I/ATLAS will change our view of space forever. The number that shouldn't exist. I keep my old notebooks in a wooden box under the stairs, the kind you'd expect to find in a British country house, dusted once a year, forgotten the rest of the time. They're filled with sketches of comet tails, calculations of orbital periods, and notes from lectures I gave at the Royal Astronomical Society in the 1980s. But the newest one, the one I started in 2025, has only one entry that matters. November 23rd, 3:47 p.m. Subject 3 I/ATLAS. Numbers 33.21 verses 33.24. I didn't write more. I didn't need to, because in those two numbers lies a quiet revolution. On March 16th, 2026, less than 4 months from now, 3 I/ATLAS will pass Jupiter at a distance of 33.21 million miles. And on that exact day, Jupiter's Hill radius, the invisible boundary where its gravity finally yields to the Sun's, will be 33.24 million miles. The difference? 35,000 miles. Let me put that in terms your hands can feel. Imagine you're standing at one end of Wembley Stadium. You close your eyes, throw a pebble, and hope it lands on a single coin placed at the other end. Now imagine doing that in total darkness, while the wind is blowing and the coin is moving. That's still more likely than this. The statistical probability? 0.004%. Or, as my old mentor used to say, once in 26,000 lifetimes. We've only ever seen 3 interstellar objects, and the third one is hitting a target that should be invisible. This isn't drift. This isn't luck. This is arrival. And for the first time in my 70 years, I don't know whether to call it physics or poetry. The invisible boundary. When I was a boy, my father used to take me fishing on the River Thames. He'd cast his line just beyond the current's edge, where the fast water met the calm. That's the balance point, he'd say. Too close to the flow, and your hook gets swept away. Too far, and nothing bites. He called it the edge of hold. Jupiter has one too. We call it the Hill radius, named after the 19th century astronomer George William Hill, who first calculated how far a planet's gravity can truly reach before the Sun reclaims its children. It's not a wall, not a line on a map. It's a zone of balance, where the pull of a giant planet and the pull of a star hold each other in perfect tension. And right at its edge? Lagrange points, cosmic resting places. You know the James Webb Space Telescope? It doesn't burn fuel to stay in place. It sits at L2, a Lagrange point between Earth and Sun, where gravity and motion cancel out like two hands holding a bird in midair. Satellites park there. Future Mars missions will refuel there. It's the quiet harbor of the solar system. And 3 I/ATLAS? It's not flying past Jupiter like a tourist. It's approaching the harbor, not entering, not avoiding, stopping exactly at the threshold, as if it knew where the quiet water begins, as if it had been told, this is far enough. And that's what chills me. Not that it's here, but that it knows where to stop. No, the nudge that wasn't supposed to happen. Comets don't steer. They drift. They melt. They erupt in random bursts of gas like old boilers groaning in a winter storm. That's what we thought. But 3 I/ATLAS, it corrected course. Scientists at JPL measured it. A tiny acceleration, 5 × 10⁻⁷ astronomical units per day squared. So small, it's almost noise. But over weeks, it added up to 62,000 miles of trajectory change. And here's the part that keeps me up at night. That's exactly the amount needed to go from where it was to the Hill radius. Not close, not roughly, exact. Now, natural outgassing can cause non-gravitational acceleration. We saw it with Encke, with 67P, even with Borisov. But those pushes are chaotic. They depend on where the ice pockets are, which way the comet is spinning, how sunlight hits a crack at 3 a.m. It's like expecting a forest fire to burn in the shape of a perfect circle. Yet here, the push was precise, directional, purposeful. If this were a ship, we'd call it a mid-course correction. But it's not a ship. At least, we say it isn't. So what do we call it? I don't know, but I do know this. Nature doesn't usually do math this clean. And when it does, we're usually missing something. 4 explanations. 1 silence. My colleagues offer 4 answers. First, it's a calculation error. But JPL's horizon system isn't some back-of-envelope guess. It's fed by 230 observatories, from Chile to Hawaii to the Canary Islands. The margin of error? 61,000 miles. And even with that uncertainty, the Hill radius match still holds. It's like saying a clock is broken because it's off by 1 second, when it's actually showing 3 hours, 0 minutes, 0 seconds, 0.01, and the event happens at 3 hours, 0 minutes, 0 seconds. Second, chaotic outgassing just happened to align. Possible? Yes. Plausible? Let's be honest. If I told you a gust of wind rearranged the leaves on your lawn into the shape of your name, you'd wonder if someone had been there. This is the same. Third, it's random chance. Given enough time, it had to happen. Ah, the old infinite monkeys argument. But here's the problem. We haven't had enough time. We've only detected 3 interstellar objects in human history. To get a 1 in 26,000 event on the 3rd try is like buying your first lottery ticket and winning, then buying a second and winning again, then buying a third and hitting the jackpot a 3rd time. You'd start to wonder if the game was rigged, not by malice, but by design. Fourth, it's deliberate. This is where Avi Loeb speaks softly, not with excitement, with sorrow, because if it's true, then we've spent decades listening for radio signals, while the universe sent us a silent traveler that knew exactly where to go. And the worst part? We have no proof, no signals, no heat, no visible thrusters, just a number, and a silence so loud it hums in your bones. Why this changes? Everything. You don't need to believe it's a probe to feel the weight of this moment, because whatever the truth is, it reshapes us. If it's coincidence, then we've witnessed a miracle so rare it belongs in poetry, not physics. If it's new comet physics, then our textbooks are missing a chapter, one that says, sometimes even ice can learn to steer. If it's a calculation flaw, then we'll fix it, and our eyes will grow sharper for the next visitor. But if it's something else, then we're not alone in the way we feared. We're not alone in the way we hoped. We're alone in the way that matters.